Alright, let's get this going. We want to talk about secants, tangents, and angle measurements. Okay, so a lot of this, guys, is just going to be simple ideas about formulas and understanding. So that's really what you need to focus on. So try to make sure you're focusing on understanding. So, what is a secant? A secant is a line that intersects a circle in exactly 2 points. So a tangent touches it once, a secant goes through it twice. So like twice does that line touch the circle. Now what does that mean? Well, that leads us to this little say theorem, that if you have two secants or chords, then the intersecting that intersect in the interior of a circle, so they're intersecting inside the circle, then what you will get is, if you want to find the measurement of a specific angle inside that circle, it is equal to 1/2 the sum of the two arcs formed by that angle. So like here you've got an example, like angle 2 here is the intersection of these two arcs, but angle 1 is the intersection, this one is from these two arcs. And so you would get those like that. So kind of keep that in mind. You need that to know that for later on, and we'll kind of go from there. Okay, so here's an example, and actually we're going to do two examples here, but let's start with the first one. I want to find x. Okay, so in other words, I want to find the measurement of angle TVU, or angle V, however you want to look at it. But I think TVU, just so that we know it's in this little area right here. Well, if you say that's equal to 1/2 the sum of arc RS and arc TU, or UT. So then you would say the sum of it's half of the 84 plus 130, and then you would easily get 107 degrees. So you could easily type that into a calculator and get that answer. Well, what about the next example? How can I make that a little bit more difficult? Well, the next answer, okay, they give us the x right there, but these two angles that you're seeing, they're formed by, they will help form, let's say, angle A, E, and B. So this angle right in here. So, well, that doesn't seem like that would help, but it does. Because keep in mind, both of these are on one line. That means they would add up to 180 degrees. So if I find this angle, then subtract it from 180, then I would be able to get the one that's angle X. Okie dokie, okie dokie. Oi, excuse please. Alright, so anyways, let's just go ahead and do this. So I'd say 143 plus 75, and I would get half of that. And if I typed all that in the calculator, I'd get 109. So I take the 109 and subtract that from 180, then I get 71 degrees. And that would be angle X. So that's your X, and that's it. You're done. Bada bing, bada boom, you got it, you're done. Yay! Let's do another theorem. Oh, let's do another example. Oops, I almost forgot. Okay. So how about this one? Well, this one, they give me that interior angle, and they got to find one of the arcs. Oh, no. So here I'm saying that the 110 would go here, equals half of the 97 plus x. Okay, so remember, the arcs, you add them up to get help you get the interior angle. But if you got the interior angle, what are you going to do? Well, how do you get rid of a half? Every time you get rid of a half, just multiply by 2. Okay, but if you do it on one side, you got to do it on the other side. So 2 times 110 would be 220. And then all that, after you got to do that, you just got to subtract 220 minus 97, you got 123 degrees, and again, there is your answer. Alright, next one. Let's look at theorem 1013. Okay, now they're saying if a secant and a tangent intersect at a point of tangency, then the measure of the angle formed is 1/2 the measure of the intercepted arc. So notice here how, like, this one is half, angle 1 is half of AB, and then angle 2 is half of BCA or ACB, however you want to look at it. So that gives me something like this. If I want to find, say, angle P or QPR, okay, then all I have to do, let's try that again. All I've got to do is take half of the 148 and that would give me 74 degrees. So that means angle QPR is 74 degrees. So this angle right in here is half of the other angle, of the arc. I'm sorry. So what happens on the other one? Well, goodness, how am I supposed to find, let's say, how can I make that difficult? Well, what if I were to tell you to find angle arc DEF? So I want this one right here. Oh, I'm reinforcing that. Okay, well, keep in mind that FD, or angle FDC, so this angle right here is half of that angle, or that arc DF. Wow, I got to stop doing that. Stubby fingers today, I swear. So that means then that this angle right here at 64 is going to be half. So if I double that, that's how you always get rid of a half, you would get that arc. So 2 times 64 would give me 128. And then that, how many degrees are in a circle? 360. So if I subtract 360 by 128, I will get 232 degrees. And that's one way to approach that. So there you go. Alright, last theorem of two secants, a secant and tangent, or two tangents intersect in the exterior of a circle. So if they intersect at the exterior point, the angle that is formed is half the difference of the, half of the difference. So this time I got to subtract it, so instead of adding. So remember, when it's inside, you add. When it's on the outside, you subtract. Okay? Keep that in mind. So, a couple more examples here. So in this one, if I wanted to find, say, angle L, then I would need to remember that HJK minus HK is going to give me, half of that is going to give me angle L. Well, how do I find HJK? Because they're only telling me 102 degrees. Again, how many degrees are in a circle? 360. So if I subtract 360 by 200, or by 102, and I'm going to get there in a second as I let this video play out, then I would get that that's 258 degrees. So I've got 258 degrees for H to J to K, and then just from H to K, I got 102. I subtract those two and then take half of that, and that gives me angle L, which is on the outside. And that should be 78 degrees. Well, how about one where I give you the degree, that angle, and I want one of the arcs? And notice here how this is a secant, so this is not quite the same thing. I can't just say 360 minus 95, because I still got this little portion that won't get touched at all. Okay, so again, anytime you have that half, and I give you this one right here on this side, multiply by 2. Okay, and that will help get rid of the half. So 56 times 2 is 112, and then arc CD minus 95 would be equal to that, so I can add 95, and that would give me 207 degrees. So this right here, C to D, is 207 degrees. That's really about it, but let's show you some things. So here's the thing that kind of summarizes this up a bit. Notice how that works. Kind of go from there. What happens if it's on the circle? What happens if it's inside the circle? What happens if the angle formed is on the outside of the circle? And that's about it. Thank you so much for your time. You all have been great. Hopefully y'all keep it up. We're almost there, but you gotta keep going. Thank you. Take care.